Hello guys, welcome again to my channel. In this video I will discuss how to find zero force member in any truss. Okay, so to find zero force member there are two rules. Okay, so with the help of this picture has been taken from the books of written by your R.C. Hibbeler. Okay, so credit goes to R.C. Hibbeler. And the first rule to find your zero force member is if there is any joint where the two member form 90-degree angle, okay, and also there is no external load, in that case both of these member are zero force member. Okay, so simply zero force member means there is no internal forces within the member. As you can see here in this picture, if you pick up joint C, okay, so in joint C there are two members. First member is member CB and second one is member CD. Okay, and here you can see there is no external load. That means if you simply apply the method of joint analysis, simply you pick up joint C. Here is your, let's say, force CV, and this is force CD. As there is no external force, you can, if you apply the equation of equilibrium, let's say this is x direction and this is y direction. So summation of fx in x direction is 0, which gives you FCB is equal to 0, and if you apply summation of Fy is equal to 0, from here you will get that FCD is equal to 0. So this is the first rule. If there is any joint where these two members make your 90-degree angle but there is no external load, okay, so of course all the two members are zero force member. Okay, this same thing also applies for joint like A. Okay, here also if you pick up joint A and apply the method of joint, so this is, let's say, force AE in this member, and let's say this is member AB, so here this is FAB, and if this is x direction, okay, sorry, this is your x direction and this is your y direction. Now apply simply summation fx is equal to 0 and summation fy is equal to 0. By solving these two equations, definitely you will get fab is equal to 0 as well as fae is equal to 0. So first rule is clear. Now come to the second rule. What is the second rule to find out your zero force member? Well, in this type of joint D, okay, so here you can see, just like the previous example, here is also there are two member, there are three member who are meeting in this joint, and also there is no external load. Okay, so if you simply pick up joint D, this is joint D, let's say this is your x direction and this is y direction. Okay, now apply the method of joint again. So at D, this is force FDC, okay, due to this member, and this is DE member, so here force FDE, and this is force in member DF, so FDF. Okay, so in the direction of x, summation of fx is equal to 0 as there is no external load, so simply FDC plus FDE is equal to 0. Okay, but in FDF it is 0 because in the direction of y, summation of Fy is equal to 0. Clear? But there is no external force as well as there is no other member in y direction, that is why FDF is 0. Clear? So we can summarize that in rule number 2, if there are two members in a single line. So here both C, D and D, E member are lies in same line. Okay, so these two members are collinear, and there is another member which may be at 90 degree or it may be a different angle with theta. Whatever may be the angle, in both cases, whether it is 90 degree, in that case also the force in the third member is 0, and in the cases where this angle, there is an angle with the third member, the force is 0. You can see here in this example, for consider joint F. Okay, so in joint F, this is force Fe, this is force Fg, okay, and this is the force Fc, okay, and this is already 0. So here you can see that these are collinear, these two forces, these are collinear, and the third one makes some angle. Let's say this is theta. So what is this force? Simply from our theory that Fc is coming as equal to 0. So here this member also is a 0 force member. Okay, so that's how to find out any trusses. You can find out the 0 force member, and here is a homework. Okay, so this is your homework. In this truss, you have to find out how many 0 force member are there and what are the name of the member who carries no forces. Okay, please don't forget to let me know in the comment section, and if you like this video, please don't forget to share it. Okay, thanks for watching, guys.